This is the second video for section 11.3. We're going to look at one theorem and then a couple examples in this video. This is theorem 11.5. It says in a circle, a diameter bisects a chord and its arc if and only if it's perpendicular to the chord. So again, we have a biconditional statement, meaning it's actually two theorems in one. So we're saying a diameter, I'll make that guy blue. The diameter is this guy. If that guy bisects a chord, the chord would be this green guy. And its arc, I'll make the arc purple. If and only if it's perpendicular to the chord. So notice how we have that right angle box there. That's what perpendicular means. So if you have that blue diameter crossing that green chord and it bisects it, and it bisects the arc, then that angle has to be a right angle. And vice versa. Let's say we start from the beginning. If we have a blue diameter and it meets a green chord at a right angle, then you know two things happen. You know that the chord gets bisected and the arc gets bisected. Okay, so we'll see how that helps us do some examples. So we're starting here with example 5. I think we did example 5 first because it's simple. We're going to find each measure in circle K. So they're telling you K is the center. We want to find the distance from A to B. That's what that AB means. How far is it from A to B? Well, you're using theorem 11.5. I put 10. Use theorem 11.5. We have a diameter bisecting a chord. So if we're sticking with those colors, the diameter is that blue guy. The chord is that green guy. Notice how they're perpendicular. If they're perpendicular, then two things happen. This segment and this segment are the same. This arc AC and this arc CB are the same. Okay, so A to D must be 7 because D to B was 7. So A to B would be 14. That's all you do. Example 3 looks a little bit more complicated. They're telling you in circle P, if segment PM notice how that's part of a diameter, is perpendicular to segment AT. Notice how that's a chord. And perpendicular means right angle. Segment PT is 10. Segment PM is 8. Find the distance from A to T. Okay, so remember what we know. If you have a diameter bisecting a chord and its arc, then they're perpendicular, and vice versa. So these guys are the same. Do you see a right triangle in this problem? And I didn't draw this to scale. But how long would that side be? That's segment MT. Remember your triples. Remember 3, 4, 5? If you multiply them by 2, you get 6, 8, 10. So the length of that missing side there is 6. So T to M is 6. How far would it be from A to M? It would also be 6. So distance from A to T is 12. Here's example 4. In circle R, you have segment RZ. Again, that's part of a diameter. And it's perpendicular to segment XY. That's a chord. So you can use theorem 11.5. You know those are the same. If X to Y is 16, that's the whole thing. R to X is 17. Find the distance from point R to segment XY. That means, in other words, how far is it from point R to point Z? Okay, so we're going to handle this one just like the last one. If the entire segment X to Y is 16, then each of these pieces is 8. And then we have this little right triangle concept again. And again, I did not do a great job drawing it to scale. But what would your missing side be? Use your triples on the sideboard there. 8, 15, 17. R to Z is 15. So even though we're basically finished with triangle chapters, we're still using triangles in circles. Here's example 6. Let's find the measure of segment KM. That's our radius. How long is the radius? Well, that radius is part of a diameter. So I drew that on there. Segment LM is a chord. And notice how the diameter is perpendicular to a chord. That means those two pieces are the same. So if the whole thing is 16, they're telling you, each of those sections would be 8. Triples again. So your radius would be 10. That's the hypotenuse of that right triangle. K to M is 10. Let's try one more. In circle Q, we have 2 arcs that are congruent. So I'm going to mark those 2 arcs. Arc KL and arc LM. They're congruent, they say. The distance from C to K is 2x plus 3, and the distance from C to M is 4x. Find the value of x. Well, notice how that segment right there is a radius, but it's part of a diameter, so I made that guy blue. You have a diameter and you have a chord and they cross, and that made congruent arcs. So what that means is that chord is bisected. Those two pieces must be the same. So 4x and 2x plus 3 have to be the same length. So we're going to subtract 2x from both sides, and then we're going to divide by 2. And I know that looks weird being a fraction and all, but that's just 1.5. 3 divided by 2. Okay, our assignment for this section, we're going to be jumping around. We're going to do the whole packet, but we're just doing certain numbers from the packet. Okay, so you're not doing all of them. Maybe pause this, circle the numbers you have to do on your packet.